Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is Lesson 4, Definition of Reflection and Basic Properties. Okay, so today we're going to be reflecting things across what we call a line of reflection, okay? So this classwork here is asking us to reflect the triangle ABC and figure D across line L and label the reflected images. Okay. Before I get into that, though, I want to show you an animation that will help you see what is going on here, because in class what I did was I had students draw figures on the desk with dry erase markers, and then I used clear transparencies and I had them copy them on the clear transparency, flip the transparency over and line up the line of reflection, and then they'd be able to see what would happen to a reflection and the original image, or the pre-image and the image. So if I bring this up, this is the website, and if I click on this, this would be the square that I had them draw on their desk, and this is the line of reflection. So there is a red dot to the left, there's a blue dot on the line of reflection, and there's a black dot up and to the right. So if I click this and drag it, we're actually flipping the paper over, rotating it around that line of reflection. So the red dot was over here where I'm pointing, and it ended up over here. The black dot was here, and it ended up over here. And since the blue dot is right on the line of reflection, it did not move. So let me do that again. So here's where we were. This red dot's going to end up here. The black dot's going to end up over here, and the blue dot stays where it is because it is on the line of reflection. So that's what a reflection looks like. Anything on the left goes to the right, anything on the right goes to the left, anything on the line stays where it is. And that's what this lesson is about. Okay, so I'm going to try to do this, and you may have your modules there, and you're trying to figure out, well, how in the world am I going to reflect this? I can't fold my paper and copy it and that kind of thing. So here's a little trick I'm going to show you, and it's going to lead to something that's really important in this unit. And I'm going to draw a perpendicular line, and you may not know what that term means, but the word perpendicular means 90 degrees, two lines that intersect at 90 degrees. So if I drew this line right here, okay, and then I rotate my ruler, see how it says 90 degrees right here? And if I bring this over here and draw another line, then that is perpendicular, and I would mark this corner with a right angle, okay, with a square. That is what perpendicular means. So that's what we're going to do here. All right, so if this dot is not moving, then I am going to put a dot right there. So I'm going to put a dot here, and I'm going to call that B. Having trouble drawing today. B prime, and that's right here. A is going to end up over here somewhere. Let me change colors, by the way. B prime is not going to move, so I'll just leave that right there. But I want A to end up over here somewhere. So I am going to draw this, and I'm going to show you that it really does work. I prefer using the metric system. It's more accurate, and the dashes are closer together, therefore we can be more accurate. So if I put this right at 0, and I measure over, and my ruler is perpendicular to this line, nice and straight, so these marks on the ruler line up with that line, I see that I am 55 millimeters from C to my line of reflection L. So if this is 55 millimeters from here, and I'll draw a line and erase it after, from here to here is 55 millimeters, and I want to reflect it around. So if I spin my paper around, well, I'm going to be the same distance away from L on the other side. So if I was 55 away on the left, and I'm 55 away on the right, well, 55 and 55 is 110, which is 11 centimeters, or 110 millimeters. So I want my line to go out to here, and my new dot is going to be here, and that is going to be my image of C, which is C prime. I will do the same with A. So I'm going to bring that over to 0. And this is, keep in mind that you want to be really accurate here, precise. Precision really matters in math, and this is where it's starting to really matter. So if I have my ruler right there, I am at about 15 and a half millimeters. So 15 and a half and 15 and a half is 31, so I'm going to go out to 3.1 or 31 millimeters, which is about right here. Okay? And this will be my A prime. Okay, and B is already here. So now let me change colors. This is just the lines I used. Now remember, this distance and this distance are the same, and this distance and this distance are the same. And B is right there. It's not going to move because it is on line L. So now I am just going to rotate my ruler, and if I put this right at 0, it will rotate about that point. So if I try to put that right on 0, roll this up to A, and I draw a line segment from B to A prime, and then put my ruler right at A and rotate it around to C, and draw a line from A prime to C prime, and then finally put my ruler right down here at 0, or B, I mean, not 0. And then I want to, now here's where it gets a little tricky. My ruler is jumping right there. Okay, so then if I draw this, then there is my triangle A prime, B prime, C prime reflected about L. Okay, so let me move my little markers out of the way here that I used to create this. Okay, and you will see more clearly what happened. So that is how you can do it on your paper. Use a ruler, measure accurately, and you are going to end up with this right here. A prime, B prime, C prime. C is the same distance from L as C prime, and A is the same distance from L as A prime is. So this is what it should look like. Now I can always check this too. So if I take my triangle and I choose all the shapes, okay, and I group them so they're all one piece, and then do the same with BC and the other two pieces I just did, now I've made the triangle all one piece, because when I draw it, it was all multiple pieces. Now if I click this and I reflect it or flip it left, right, okay, and then move it to the left, it is identical to the original drawing. Pretty cool stuff. Okay, so there's reflecting a triangle across a line. Number 2 says, now let me put that back. Number 2 says, which figures were not moved on the new location on the plane of the transformation? So what did not move in this? Well, A moved to A prime, C moved to C prime, B is right where it was. So point B, let me write point B, did not move because it was on the line of reflection. Okay. Okay, so there we go, a little bit neater. Point B did not move because it was on the line of reflection. Okay, so now we're going to do figure D. Well, that's going to be really difficult to do because we only have 2 vertices to measure. If I were to measure over to here and then over to here again, I will do that just to get a location, and I'll show you how I'm going to do this. I'm going to put 0 right on that line and make sure that they line up so it's perpendicular. Right there. And if I read this, it's 51, 2, 3, about 53, 54 millimeters, about halfway in between. So if I come over here and put that at 53 or 4 right there, about, let's see, yeah, right about here. And now my point is going to be right here. Okay, so this point right here is this point right here. Okay, now I'm just going to copy this the best I can. And I'm going to use a straight ruler here. And then I'm just going to do the best I can here. Really careful to try to stay on that line. Went off a little bit there, but not bad. Okay, so now I'm going to make that one figure. And I'm going to flip it left to right, which is a reflection, and I'm going to move it over so that that corner that I marked and measured is right there. So that would be figure, and since it's the new one, it's figure D prime. Okay, we got a little bit out of control right here, but other than that, that's pretty close. Okay, so the other way we could have done it, we could have also measured from here to here, and then duplicate that over to here, and then maybe the maximum point here over to the maximum point here. The distance from here to here is the same as the distance from here to here. Okay? All right. Next problem. Now it says to reflect the images across line L and label the reflected images. Okay. So again, I can get my ruler, and I will do this just to be accurate, because this is basically the only way you can do it with on your paper without what they call patty paper. I don't even know if anyone uses that anymore. So this distance from here to here is 6 centimeters. And I'm going to move my ruler over to 0 now. I could have done that or just left it where it was. Let's just leave it where it was and extend that line out to 6 times 2, or 12. Okay. And that's right there. I'm going to do the same here. Line up that point there, and it's 13. So 1 to 13, or 0 to 13, and then 13 to 26 is double. That's not 13, that's 18. 18 and 18 is 36, which is right about there. And then move this up to A. So we're looking at about 44. 44 and 44 is 88, which is right about there. I can be more accurate with my eraser than I can with my pen. Okay, right about there. Okay, so now I want to, this now is B prime, this is C prime, and this is A prime. Now it doesn't look like much yet, but now I'm going to connect A, B, and C. So when I put my ruler here at 0 and rotate it down to C, like so, let's change the color to purple this time. There's my line segment, B prime, C prime. And then if I swing this up to A, this is my B prime, A prime side, or angle. And now I'm going to mark this like so, and then I will erase these lines. Oh, don't want to erase everything. Okay, so there's the reflection of my angle. Now what they want you to realize here is if I took a compass now, or not a compass, but a protractor, and I bring this down, and hopefully you know how to use a protractor from last year, and you put the protractor here right at 0, line up this side, and then grab your measure and bring it over to A, you can kind of see it in behind there, and you see that it is pretty close to, I'd say, 66 degrees. There's 66 right there. It's pretty close. So now I want to bring this over here, rotate it so that it is right on that line segment, B prime, C prime. Get my measuring device, swing it over to my new line, and now we have to look inside, and it looks like it is about 66 degrees. Okay, very close. So we now have confirmed that if we reflect something across a line, reflections preserve angle measures. 66 degrees, 66 degrees. Okay, now I'm going to take my compass. This is the only way we can do this on paper. And let's change the color to green. And I need to find the center of the circle for starters, so let me do that. Okay, so here's what I've done. I found approximately the center, which is right here, and it looks like it is approximately 22 and a half millimeters from the line L. So I'm going to move this over until I get to about 22 and a half, which is approximately there. And I'm going to put a dot here. So my center is going to get moved from there to there. Okay, so now I have my compass, and that is the center, and that's about the size of the radius. So I'm going to move this over here, and I'm going to draw my new circle here. So there's my circle. Now all I need to do is measure over how far this dot is from the line, and point I is exactly 1 centimeter. So if I move this to 1 centimeter, line it up and put my dot here, okay, that is I prime. Do the same up here. That looks like just shy of 25 millimeters, or let's call it 24 and a half. So I'm going to move this over until I get to 24 and 1/2, which is about there. And I'm going to draw that dot right here. And that is J. And then I'm going to measure from J, or not measure, but draw a segment from J prime to I prime. So there's my reflection of my circle. Okay. Now I'm going to answer some questions about these. Use the protractor to measure the reflection of ABC. What do you notice? Well, I've already done that. Angles, measurements, let me call it angle measurements, are preserved, get rid of that, are preserved under reflections. So therefore, this is also 66 degrees. It says use a ruler to measure the length of IJ and then the image IJ after the reflection. In other words, I prime, J prime. So if I take my ruler out over here and I measure IJ, that is just shy of 2 centimeters. Looks like about 19 millimeters, 19 and a half millimeters. Now if I move this over here and do the same here, that is also just shy of 2 millimeters. So they are the same. And I will say segment lengths are preserved under reflections. Okay, moving along. Now it says to reflect these figures. Okay, it's the same process, so let me speed this up a little. Okay, so from this corner, or from this point right here to the line L is 2 centimeters, so I'm going to go 2 more on the other side, and that will be 4, so I'm going to put a dot right there. Okay, and then move this over to here, and that is also 2, so I'm going to put a dot here for 4. Okay, now I can quickly rotate that to 0 and draw a segment from here to here. So there's my side right here, down here. The rest I'm going to just try to do freehand. Actually, let me just do the point, and then I'm going to cheat because I have my computer. This is 58 millimeters. I'm sorry, no, this is 38 millimeters. 38 and 38 is 72, which is right here. Okay, so this is going to curve around like this, but I'm going to trace this like so. So I'm more accurate. I'm going to now choose that. I'm going to flip it up, down, and I'm going to drag it down here so it's on that. So it should be like right here. Okay, and then get rid of that, get rid of that, and that's approximately what my figure looks like there. And that's figure R prime. Okay, now in order to do this one, leaving my ruler at 90 degrees, you can't do that, but you can use your lines on the ruler that make it look like it is perpendicular. I'm going to put my ruler right at 0, and I see it's 4 millimeters, so 4 plus 4 is 8. So 8 is right here, and then I'm going to move it over to here. And that is just over 15, almost 16. So I'd say 31 would be a pretty accurate double. So we're doubling the length here. And then C is below, or this is G, I guess. And if I put my line right on there, it is at 12. So if I move this up to 24, like that, and draw and put a dot at 0, now I am 12 millimeters above the line L across from G, which is actually more over here. More like right here. And that will be G prime. This is F prime. And this is E prime. Now I'm going to connect those points. So I'll put my 0 right on E. Rotate it so I'm at the point F, which is right here. And draw a line segment. Rotate this up. Like so. Move this over to F. Rotate it to G. And there is my E prime, F prime, G prime triangle. So, basic properties of reflections. 1, a reflection maps a line to a line, a ray to a ray, a segment to a segment, and an angle to an angle, or a shape to a shape, a semicircle to a semicircle. A reflection preserves lengths of segments, the lengths don't change, and the reflection preserves the measures of angles, they don't change. If the reflection is across the line L, and P is a point not on L, like right here, then L bisects and is perpendicular to the segment P prime. So all they're saying is this bisects, meaning cuts it into 2 congruent pieces. They're both the same length. So if I reflect P over to P prime, the segment PO and OP prime have the same length, and that's what that says right here. Okay? And now it says use the picture below for exercises 6 through 9. It says use the picture to label the unnamed points. So I have a triangle reflected from here down to here, and this is R. So this would be R prime. This is I, or is that an I prime? I guess it is. It's hard for me to read that. Just give me 1 second. Okay, now that I've got the actual addition in front of me, the teacher's addition, that is actually a J prime. So this is j. Okay, let me use lowercase j. That's j. K is here, so this will become k. Oh, I'm sorry. No. Oh. K is the furthest one away. K is way down here. This is k prime. I is right here, so this is I prime. 28 degrees, so this is 28 degrees. And this is 31 degrees, so this is 31 degrees. This is a reflection of figure A. Figure A is here. And this is the point F. So this is the point F prime. This is the point H. This is the point H prime. And over here we have angle CBA, or angle ABC, reading it this way, or just simply angle B. The point C is across right here, that's C prime. B goes here, that is B prime. It is 150 degrees, so therefore this is 150 degrees. And angle A, or not angle, but point A becomes point A prime. So there we've labeled everything up. Oh, HF has a length of 4 units. H prime F prime therefore has a length of 4 units. Because distance is preserved and angle measures are preserved. Length and angles are preserved. Okay. D is sitting right here. D prime is also sitting right there. It did not move. It is right on the line. That is D prime. 7 says, what is the measure of angle JKI? JKI is 31 degrees. So I'll say the measure of angle JKI equals 31 degrees. That little M in front of the angle symbol means measure of angle, and then you name it. Then to answer this question, let me change colors. The measure of angle KIJ, and I like to put a little angle mark here so it doesn't look like a less than symbol. The measure of angle KIJ, where is that? KIJ, 28 degrees. And the measure of angle ABC is 150 degrees. What is the length of segment reflection FH? So F prime, H prime. So I would say F prime, H prime segment equals 4 units. What is the location of reflection D? I would say it is at its initial location because it is on the line of reflection. Okay. All right, enough said about that. And lesson summary, I will leave that to you. This is the end of lesson 4. Go do your problem set.